with page 2, we're dealing with momentum conservation. So we have a cannon firing a ball 15 kilograms. Here's the speed. The cannon recoils with another speed, and we want to know the cannon's mass. So let's be clear with what's going on. Let's call this M1. And this will be V1 initial. The cannon itself is an unknown mass too. And actually, I just realized the firing speed is actually the final speed of the cannonball. And the cannon recoils with the speed V2F. And one other thing we're going to say is that V1 initial equals V2 initial, which is 0, because they start from rest. This is momentum conservation. So we have M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. So 15 at 0 plus the unknown cannon mass at 0 equals M1 going forward, to be clear, M2 at 0 equals 15 going forward at 75 plus our second mass, which is the cannon, recoiling at a speed of -2. So make sure we write that backwards. So what this leads us to is that 2m2, when we rearrange, is going to end up being 15 times 75. Which is 1,125. So when we actually solve for the mass of the cannon, we're going to divide by 2 to simplify, and we end up getting 562.5 kilograms. All right, so we have a 3,000 kilogram car at rest hit by a 5,000 kilogram car going at 8 meters per second. They hit and stick. We want the final speed. So let's call this M1. And at rest, change colors here so we know that we're talking about different problems. And I'll just move this up a little bit. How about that? So here's the idea. Oops. So the idea is we have this car right here, the 3,000 kilogram car. We'll call that M1. It's at rest, so that means V1 initial is 0. It's hit behind by a second car, which I'll call M2. Its initial speed or velocity is 8 meters per second. And then they hit and stick. So that means we have V2 final equals V1 final. This is the same speed, so I'm just going to call it plain old V. Let's now solve part A. M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. We put in our numbers 3,000 times 0 plus 5,000 going at 8 equals 3,000 going at the final V plus 5,000 going at the final V. I can now combine these terms. This is 0. This is 40,000. This is 8,000 times V. We're going to divide both sides by 8,000. And so we end up getting 5 meters per second is the final speed. Now for part B, let's just compare kinetic energies. So the initial kinetic energy is just the 5,000 car. So it says how much energy is dissipated in the collision. I said compare initial and final energy. Well, there's only kinetic energy. So E kinetic energy initial is going to be 1/2 times just the 5,000 car going at 8 meters per second squared. 8 meters per second. And then we square that. So when we actually do that and we get its initial kinetic energy, that's going to be 160,000 joules. Now, the final kinetic energy, we're going to say that the cars hit and stick. So let's just count them as one mass, okay? So we'll think of them as one mass of 8,000 kilograms at 5 meters per second. So that'll be 1/2 times 8,000 times 5 squared, which is going to be 4,000 times 25, which is 100,000. So when I actually get the difference here, it's going to be 160,000 minus 100,000, which is going to be 60,000 joules. Okay, I'm going to do something really embarrassing here. Here's the deal. Josie, if you're watching this, I remember you checked with me and you got 20,000 down here. And I can guarantee what happened is that you forgot to square this. So if you're looking at this video, go back and check, because I remember distinctly that you got 20,000. And for anybody else who's in the same situation, please go ahead and double check that, so you're losing 60,000 joules. So that is the conservation of momentum portion of the exam, and we'll move on in the next video, I believe, to momentum.